Hello, and welcome back to Information Storage and Retrieval Assignments. We're gonna keep moving right along here. So if you recall last time, we took raw documents. Here, let me reload this page. We took some raw documents. In this case, these are just the lines, a handful of lines from Green Eggs and Ham, right? As I've been the constant companion this semester. And we split them up into a collection, and then we built an index. Last time we went through a lot more steps, but this time we're actually going to just kind of do some skipping. We're going to build a function that will do all of that sort of at once. And then we're going to move on to beginning to handle the user input, the query. We're going to split that into tokens, and we're going the same way that we handle the collection when we normalize and turn those into tokens to create our terms. We're going to turn queries into the same kinds of terms, and we're also going to pull the postings out to those particular queries. So in this example, if I did would you, we see that capitalized, let's say, well, a bunch of question marks, whatever. We're going to do the same, normalization and cleanup process to those tokens. And we're going to write a function to go and retrieve the postings from the index. Ooh, so this time we're actually going to this process to get the query postings for each term in our query. So for would, go get its postings, and you go get its postings. This is the first time we're actually going to be using two sources of information, the index and the query tokens we'll use, and then we'll go and get the postings out. We have a long way to go before we actually process the query. That'll be for next time. But for now, we're just going to focus on how do we actually pull postings out of an index in the way that we've built it. So that all said, and remember, this is fully interactive. You can add new lines if you want. Would you like them in your hair? I do not like eggs in my hair, right? And that's just an even worse line. What a jerk this narrator is. But now we see that everything is updated, right? We have would you occurs in many more lines now. We have, I guess not many more. We have would occurs in, let's see, 6 different lines, I think, maybe only 5. 1, 2, 3, 4, 5. Okay. So if we look at that, would exists in 0, 3, 5, 6, and 7. Great. So that tracks, right? This is making sense. And then when we go to process a query, we're hoping, okay, so would pulls out those same IDs, and then you is going to pull out different ones. But again, we will then work on the intersection algorithm and how to process efficiently process these postings into, the overlapping documents, the intersecting documents. Okay, so that's plenty of thoughts on the matter, I think. So now we're going to work out the process. As usual, as we're drilling in from the surface, let's start looking at. I can close that old friend. Let's start looking at what are the actual function names that we'll be using. And this should look familiar. Again, this is the same design as so many of the assignments before. Lots of style stuff going on. We have a handful of boxes, which are the boxes here. And then we get into my helper functions, and specifically the update function is where we can see, okay, what's the work to be done today? So let's look. First, we need to build the collection box, which is this one. We're going to use the same function that we already used last time, split documents. The reason we need this is that ultimately when it comes time to grab text out of our collection to present as a result, we need them split up. So we still need that first step to split, even though it's basically free. You already have defined this, so this will just automatically happen in your library. Then we're going to build a function to process from the split documents. We're going to build one that just does straight from that to an index. We'll cover what that is, but if you remember last time, it's just kind of the aggregate functions we did to normalize all of the text of all the documents, split the text into tokens on all the documents, and then build the index out of those. We're just going to do that all in one step with a new function, which just combines all the old stuff. We're also going to build another kind of wrapper function for a bunch of things we already know how to do, which is processing your query in the same kinds of text, right? So we're going to take this query, would you, and we're going to process it into the query tokens and more or less the terms, right? The normalized, tokenized terms of the query. And finally, we're going to take those tokens from the QTerms box here and the index that we just built on the collection, and we're going to go say, hey, find those postings. So give me those postings, and I'm going to drop them into the QPosts box, which we will use in a future assignment to actually do the intersecting, the getting of documents. I guess one last thought is, no, we're good. Okay, so right now this works. As usual, I'm going to destroy that. I'm going to throw away the old library that I'm using, the one that I used to make this work. And oh no! Come on, reload. Oh no, it's broken. Oh no, of course it is, because we don't have any functions. Because this call to say, hey, where's that file that you had, no longer exists. So clean slate. As usual, you can copy your old irsyslib over into the new folder. Well, shoot, I can't do that within that particular thing. I need to do it down here. So point being, get it in there somehow. Oops, first of all, that was the wrong thing altogether. Second of all, I've done it silly. So watch and learn how to not do it silly. Okay, so now if we look at this is the same document you used last time, right? We have our old assignment 1 functions, which are kind of the basic stuff. Trim the text, lowercase it, strip punctuation, normalize all 3 of those at once. Great. These are the things that we're going to use to process our query. Neat. Okay. So then we have our assignment 2 functions, which are splitting a whole set of documents, normalizing a whole set of documents, all that good stuff. And then we do our complicated indexing process we saw before. So now we can get started on our assignment 3 functions. Okay. What are the functions we need? As usual, before we move forward, real quick, I just want to demonstrate you've already defined one of the important functions in your library. It already exists, the split document. So if we reload this page, hey, okay, cool. The collection's already being collected. Good. So now we need to focus on how are we going to get the index built out of those? Well, what's the name of that function called? It is index collection. Just copy it, and then we're going to build a function, right? Function index collection, and we're going to take the collection, right? The collection of documents. We'll just call it collection for now. So this function, when it gets called up here, right, it's going to take in whatever's in the collection. So a bunch of split now, but still raw document strings that we need to process as usual. So last time we learned to do that using our friends tokenized docs and normalized docs. Let's just go ahead and do that. So let's call a new variable let docs we're going to put the collection right in it. Okay, so now we'll say something along the lines of, what's the first thing we need to do? We need to normalize all the text. So docs equals normalize docs of docs. So we're going to say feed this collection that we have here, feed it through the normalize function, and then set it back to the same value, as in this value will get updated with the normalized version of the documents. if we want to see if that's working, well, let's not do that yet. So, okay, that's the first step, right? We have to normalize the documents, and then we're going to need to tokenize them, and then we build the index out of those tokens. Great. So we're partway there. We can just keep using the same variable. It's a little bit slightly hacky to do that, but it makes things a little simpler. We are just continuously changing the form of this collection over and over. So normalize docs. We also need to tokenize docs, right? So now this value had the normal strings in them from the collection that we pulled down. We've updated it to be the normalized version of all those strings. And then we're now updating it to be the arrays of tokens of all those things. Okay. And finally, we need to build the index. And that's going to be, well, we have a function for that. We have the tokenized documents. So now we can call our old friend index docs on it. Index docs on docs. Because, as we can see, this now contains the tokenized version of its previous form. So if we do this and we return the index, the hope is it will work. If it reloads. It did it! Oh my goodness. So let's slip some things in here so it's a little bit more clear though. You know, I sometimes we get ahead of ourselves. So one good thing to do when you are building a program, console.log, whatever thing you're working with right now, just log it every so often. So in this case, I'm going to log the documents as soon as they come in. I'm going to do the same thing every time I change them. And then ultimately the index is already being printed out here, so we can just kind of leave that. We're going to look for in the log or in the console. I think the console, yeah, it got a little smushed. We're going to just see what happens in the console. Okay, so this can help illuminate a little bit of what's happening when you build a more complex function like this. Okay, at the start, we pull in these normal document strings as they already existed. Cool. Then we have normalized them. Okay, cool. We see the difference now, right? Would you like green eggs and ham? I do not like them. All the lower cases, no punctuation, all good. And then finally, we have the tokenized versions of each document. So this is a bunch of arrays for as many documents as we have, and then each array is the words, right? The tokens. Finally, we know we can take that and throw it through our indexing function to, ta-da, build the index. So there we do. We have it. It's done. Great. So that's it. The whole idea of this is we want to have a function to jump straight from collection to index without doing all the middle steps. It's just a wrapper. You know, we're not doing anything fancy here. We're just saying, hey, old version of these functions come together in this specific way. Reusing what we've already built. We built the tools. We're now going to reuse them. Another good thing to do is after you've done this, go ahead and comment these out. Like as soon as you're satisfied that your function works the way you think it should, you don't need to keep printing things out to the log. It's just sort of to help you figure out what's happening. So now we see, okay, great. So this is still busted. That's fine. We haven't done that yet. Doobie-doobie-doo. Of course it's still busted. So let's fix that one. If we look, we now need to process the query, right? Which is going to take this raw input query. We'll think of this as the Google search bar. And it's going to turn it into normalized tokens, much as we do with everything else. So let's do it. How do we do that? We have some tools available. And if you recall from the lectures, from the discussions of all this, as long as we use the exact same process to normalize and tokenize a query, then it's still speaking the same language as our index, and thus they will work together. So we need to reuse, thankfully, reuse things we've already built. what's the name of it again? Process query. So let's make a new function. And it's going to take the query text. Doesn't matter. We can call that whatever, but we just, for our own sake. And let's give it function to tokenize query input, right? So we got to get this speaking the same language as the others. So what we want ultimately is the query tokens down here. So how do we do this? We have the query text coming in, right? We have whatever is being dumped out here. So let's say let text equal the query text. I like to make it sort of anonymized here sometimes. So, okay, we need to normalize this text and tokenize this text, right? Those are the steps involved in making sure we are in terms land instead of just raw text. So we can skip past these ones that do the docs and the tokenizing docs because those are more complex than we need. We just need the one that changes a single string, right? Hey, back to assignment 1. So we can normalize any text and we can tokenize any text that, assuming it's already normalized. So great, let's do that. So we're going to say the text in this function is going to be the normalized version of that text. So it'll be updated with that. And then we're going to update it again. Actually, I guess this would be the tokens now equals tokenize. That text. Started typing while I was saying words. Okay. Does this make sense? So we are saying, hey, the query text is coming in. It's coming in from the user. I'm going to store it in this variable real quick, just so I don't accidentally screw with the original version. Sometimes that happens. So I'm going to change this text I'm going to use my normalize function that I've already defined to change the text to the normalized form. And then I'm going to tokenize that text and store that in the variable tokens. Now, that's what this is supposed to do. This is processing the query into some query tokens. So let's, I guess we just return the tokens, right? Let's see, is that correct? Is this going to do what we think it should do? Let's run it. Oh, I did something wrong. Normalize. Oh, because it's spelled foolishly. Now it's spelled like a function that we named once. Aha! Hey! Oh, look, it's doing a thing. What if I searched for would you? Hey, good. What if I searched for would you? Good. These are normalized query terms. These are the tokens that we will use to go to the index and say, hey, where are these documents? Where do they live? Great. Okay. So now we need a function to go and get them, right? What's that one called? Let's see. So this one's going to be called find postings. We'll go ahead and copy that. And it's going to take two different things. It's going to take the query tokens that we just got, but it's also going to bring in the index. And we're going to put it all out into QPosts, this final bit. So this is the first time we're going to be defining a function named this that will take query tokens and an index to do something together. So this is arguments, right? We are supplying, we've been doing this a lot. Normally it's one thing at a time. Just, oh, here comes something that is being passed to this function that it can do a bunch of stuff with, right? Well, in this case, we're doing it with two different values. In this case, that is the tokens that we just generated and the index we generated earlier. Fantastic. So what do we want to do here? How do we get these things? Well, moment. Okay. Consulting some notes and taking a breath. So there's a few ways you could do this. The general idea is that we want to build, I guess, sort of, if you recall, what we're going to ultimately do is we're going to cycle through the postings list for each term in our query, and we're going to do that intersection algorithm, right? We're going to say, trying to go from bottom to top, like, oh, is document 1 in both of these? No. Is it document 3 in both of these? All that good stuff, right? So what we want out of this is an array, a list, a whole set of postings lists, one postings list for each token. So I'll write this down. Returns one list of document postings for each token in the query, right? Okay, let's get this started. How do we begin? Well, remember, we're going to be returning a list of lists. We've done this quite often. For each term, we're going to need to get the postings list. Oh my goodness, get out of here. I need to turn off Discord notifications entirely. Okay, so let's see. Right, okay, so we're going to let query postings, actually I prefer camel case, equal an empty array, right? We just need to set aside a space to start adding postings to it. Now, let's talk about our index. This is, remember, we're working in objects in many places known as hash tables, and it can be kind of easy to forget what the heck is going on in them. So let's pull one out real quick. If I use my get function, we'll say var x equals get index. I believe that'll pull it out. So what does x have? Good. Okay. How are we going to pull things out of this index? This is where the power comes from the fact that we've already normalized our terms. This is actually quite easy. Remember, the index is a hash table, so you can give it words, right? So if I say x sub and, that is the postings list for and. So let's go to and real quick. And, right? It's at this location, the word and what is it? It is this array. That's exactly what we need. This is the postings list, and it's the only thing in and. So if I say x of wood, well, that gives us the one at the top. Thank goodness this is so easy. This makes it quite simple to pull these postings out, which is fantastic. So that's the only thing we need to do to retrieve this. So, sorry for the pauses. I forgot some of the flow of this function. So, okay. There is a case, though, that we need to do something a little bit more carefully. What if the term that the user has entered, is not in the index? So let's say in x of blorgle. What happens? Well, it returns undefined. This is something that we're going to dodge right now by being careful in the way we design this. You can't work with undefined. So we're going to have a check in here to say, okay, if the term is not in the index, then we're going to just give back an empty list. You'll see why that's important next time when we're actually processing these things. Because it's valid to have a term that doesn't show up in the document collection at all. That's totally fine. But you don't want it to blow up your system. So here's what we're working with. We're going to go through the list of terms, the Q tokens. So for Q of Q tokens, and remember, what does for of do? For of says, oh, you have an array of things. You have a list of things. I'm going to pull each one of those out into this variable, and we're going to do the same thing on each one. Okay, good. So that's fine. that means for each term that we've got, I called it Q. Yeah, it's fine to call it Q. You can call it whatever you want, but Q is nice and resonant here. So we need to check. First, we need to ask, is this term present? If Q in index. So actually, let me write a couple of notes here. It's always good to do this for your sake and mine. For each term in the query, if the term is in our index, then what do? Well, thank goodness. Remember, this was actually quite simple. What did we do to pull out the postings list from the index? We said index, whatever it might be named, give me the term, right? So if my, let's say, we'll do var down here. Our Q is wood, right? So now if I say x sub Q, aha, it pulled it out. So what do we have stored in Q? Ooh, we have the term stored there. So if the term is actually in the index, then we're going to we push, right? We can accumulate values into the query postings by pushing them. So let's just do that. Query postings dot push, and then the index, which we have access to right now, is called index from the argument, index sub Q. What does that do? Add the terms postings list to our result, I guess, right? The result that we're going to return. Remembering that we're trying to end up with a list of postings for each term in the query, right? Which we will then run the intersection algorithm on and pull them all out. Okay, that's if it's in the index. If it's not, we need a secondary case where we will do the same thing, but we're going to give it an empty list. And again, you'll see exactly why later, but the fact is that this is actually quite useful. This allows us to shortcut a lot of things. If they enter something into the query that doesn't exist in your entire collection, that makes it actually quite fast to just run through the other queries and be like, oops, there's nothing here. So this is kind of it. This should get us there, I think. So we're going to find postings. We're going to, so the find postings is the action we're taking here. We're giving it the tokens from the query and the index. We're setting up a space to hold them. We're going to run through for each term. We're going to then add the postings for that term from the index. And if we don't have the term, we're just going to add an empty list. So what should this look like? Well, let's return it and see what happens. Farewell to our friends over here. Ooh, it looks like it's working. It hasn't blown up. That's for the best. In this, if I type the word wood, ooh, we have a list of lists, right? It's a nested list, but we have a postings list. What about you? We have the same wood postings list, and we have another postings list. Now, with your human eyes, you can see that these overlap, 0 and 3, 0 and 3. That's going to be our result. But we have to build the algorithm to do that efficiently. And that'll come next time. But just to flash forward, let's say, let me grab out var just into X, some random bin, right? Give me the Q posts, I believe it's called. Ooh, it blew up. That's not correct. Maybe lowercase. There we go. Okay, so this is the result, right? 0, 3, 4, 5, 0, and 3. if I wanted to pull out one of these documents, which is where ultimately we're heading, right? We're speaking about the documents in terms of their addresses in the collection. Well, let's get var call equals get the collection out. Okay, so call has the collection of the documents. Cool. Good. So let's say I want to pull a specific one. If I want x sub, no, we don't need that, sorry. Sub 0, right? The first query term, and we want its first value. Sub 0. Okay, so that's 0. If I want to pull this out, now I'm demonstrating this because this is a string, and that might not seem like that's compatible. Turns out in JavaScript it is. So if I said, give me the 0th document in the collection, sub 0, it still does it. There's a lot of leeway, and honestly, we'd be a little more careful in another programming language to make sure everything was like stored properly in integers and stuff for the indexes. But for now, we don't have to worry about it. The point is that we can see now that each one of these, so this 0 means line 0, the very first line, right? This one. Oh, I missed this one. If I want this, the 1th, so call sub 1, I get the second line. So these postings are the locations of where to go to grab out specific documents from a collection. Okay, that's it for now. This is ultimately it, right? This is there's 3 functions you're trying to do today. One to index a whole collection kind of all at once. One to process a query into a good form, right? And then one to find the postings of that query. And that's it. Yeah. So good luck on that. And as always, if there's any questions, you got it. Take care.